Textual data by being trained on essentially the totality of all publicly available text on the web, right? Typically 10 to 20 trillion tokens. A token is like a subword unit, it's about a word. So it would take you or me maybe 100,000 years to read through this kind of material, so that looks like an enormous amount of data. So the obvious thing is, the obvious idea, which we've been playing with for 10 years, and largely failing until recently, is why don't we use the same idea to train a system to understand the world? The way perhaps animals or humans learn to understand the world, right? Babies open their eyes, and within a few months they really understand that the world is three-dimensional, that there are animated, inanimate objects. Within a few months they understand the notion of gravity and physical intuition and things like this, right? So we understand the world by learning mostly from observation. How can we reproduce this in the machine? The obvious idea is use the same idea that we use for text, take a video, remove some parts of the video, and train a gigantic neural net to predict what's missing in the video. For example, take a video segment, remove the last half of the video segment, and then train the system to predict the second half of the video from the first half, right? If the system is capable of doing this, then it will have understood the nature of the world, right? It will understood that objects can move independently, and perspective changes when you move the camera, all kinds of things about the world, like babies. And that doesn't work, and we've tried to make this work for 10 years. It's not a new idea, it's a very old idea. But there's been a bit of a breakthrough, what I think is a breakthrough, over the last 4 or 5 years, where we realized the best way to do this is to not have the system actually reconstruct the input, not have it predict what's going to happen in the video in all details, which is the idea of a generative model, right? We talk about generative AI and generative models. A generative model is something that generates the inputs. The solution we find to that problem is non-generative. So it's the technique which is called JEPA. That's an acronym that means Joint Embedding Predictive Architecture. It's a mouthful. And the idea is basically you take the video and you run it through an encoder that produces an abstract representation of that video. Then you transform or corrupt that video, also run it through an encoder, and then you train a predictor, but the predictor is trained in this representation space, in the abstract representation of video. So the system doesn't have to waste resources predicting every detail of what goes on in the video, which are really completely unpredictable. So that idea is really kind of a new concept. I mean, the concept actually is quite old. The basic idea of this goes back to a paper in the early 90s, but not for video at the time. But we kind of rediscovered a little bit this idea, and we are kind of working on training systems to understand the world this way. So a system that you have them observe a piece of video, it extracts a representation that might be the idea that the system has of the state of the world at a particular time, and then perhaps you observe an action that either the agent itself takes, or maybe someone else takes, and then you train the system to predict what is going to be the state of the world after I've taken this action. And if you have a system like this, it's called a world model, predict the state of the world at time t+1 from the state of the world at time t and an action you might take. Then you have a way of predicting what the consequence of the sequence of action is going to be, which means now you have a system that is capable of planning, because it can figure out by search what sequence of action can I take so that I fulfill a particular goal or an objective. I call this objective-driven AI. It's a very general concept, it's not a new idea either, but that might be the architecture, future architecture of AI systems that might be able to reason and plan and understand the physical world. I've written a long paper about this 2 years ago, which is publicly available. I gave also technical talks on this. And the interesting thing is, it's not a generative architecture. It doesn't involve LLMs. It involves world model, and it can plan. And reasoning is kind of a special case of planning, so it can do all of that. So that's kind of the hope that we have for the next few years. There's a lot of details to fill out there. It's a conceptual idea, but it's going to take 5 to 10 years.
Is this a 10-year plan then?
It's something like a 5 to 10 year plan, yeah. I mean, I think you're going to see effects of this in practical systems in kind of shorter term, perhaps in a few years. But my prediction is that perhaps 5 years from now, nobody in their right mind would use LLMs, actually. They'll be out of date, perhaps put out of commission by systems of this type that are objective driven.
Okay, so let's say that you